Hello and welcome to the C++11 Beginner Tutorials by Gamer2Creator. I'm Chris. So it's been almost a year to the day since I've posted a video, but I am going to pick up right where we left off, right after the input-output streams. We need to cover pointers and references. These are key topics for C++. We're going to start with references, and then move on to pointers in the next lesson. So what is a reference? Well, references and pointers are very similar in that they allow you to either reference or point to another variable somewhere else in your program. Let's say we have an int size, and we'll set that to 10. This is a regular variable size. It's an integer and it has the value of 10 in it. Now we can reference this int reference. Let's say the size equals size. Now we've created a reference. The little ampersand symbol here means that we have a variable that references an integer. And we've bound this reference to the variable size right here. Now it's important to know that we're not copying size into a new variable like we would if we did int new var size equals size. Now in this one, we've copied the integer size and stuffed it in a new variable called new variable size. These two, the differences between these two things are going to be very key to understanding what C++ is all about. It's all about speed and being able to get to other objects in memory quickly without needing garbage collection or like shared pointers all the time. But it's up to you to not abuse them. Now where this is going to come in very much handy is when using functions and classes and these kind of things. And since we've already covered functions, you know that int main is a function and it's the first function that gets called in your application, except for constructors of global variables. So let's make a int check value. Actually, we'll call it bind value. Int low, int high, int results. Now here we wrote a function and we actually don't need to return anything. Here we wrote a function that takes in a low and a high integer and a reference to another integer called result. And what we want to do here is check if result is less than low, result equals low. If result is more than high, result equals high. And I did the brackets different, but both of these will work. And we don't have to return anything. We're not returning any data, but we're going to, because we have a reference to another variable, we're going to actually change whatever variable we send in as the result. So let's get rid of these. Let's say we want our low to be 100 Hi equals 150. And this is just one of infinite number of examples that could have been given to explain how references work. You'll be using them in different ways all the time. And then we can call bind value. We need our result though. We're gonna say, let's make it 50 for now. We'll say low, high, result. And these variable names, as we discussed before in the functions videos and stuff, that these names don't have to match when you call the function. This could have been called anything. It'll be passed into here as a copy. So low will come in here and it'll be copied by value. And this will be a whole new integer on the stack. Same with high. Now we'll have a reference on the stack, but that reference will be referencing something back here in this function, which is also on the stack. But we're going to change result. We're going to change this variable in this function within this function in this code because it's a reference. And I'm going to prove it to you in the debugger. Okay, so you can see that we have low is equal to 100, result is 50, high is 150. And we're going to step into this function, step over, and now you can see that low has been copied, high has been copied, and result would appear to be copied. As you can see, the type is a reference, and the value of the object it's referencing is 50, which is result. Now I'm going to pin this right here. This is the name of this value and its current value. Now I'm going to come up here and I'm going to pin this. So you can watch the value of result from this function and the value of result from this function as I step through. Now this if block just triggered. And as you can see, this line of code fired and we set result to low, which was 100. You can see the value actually changing in the debugger. And then we'll go ahead and finish the program and it returns. Alright, but what would happen if this was just an integer? So now we have low, high, and int result. They're all going to be copied. So let's watch. As you can see at the start, they have junk values because they haven't been initialized yet. Now that one has been initialized. We're going to step into this function. Now here we are. This is where we were just a minute ago. Only instead of having a reference result, we have its own variable that was copied from this result. And it says that I hate it when it does that. Alright. To better explain this, I'm going to make this result ref because it's getting a little, well, a little complex. Result bound. We'll call it result bound. I just wanted to rename it so that these two results don't have the same name. We'll try this again. Step over, step over. Alright, so now that this variable has a different name, it's still an int and it's still been copied. And there we can see what I was expecting to happen that this has been changed. And if I go right up the call stack and come back up here, you can see when I jump back to main to view the local variables here, you can see that result has not changed, but result bound has. And even though we set result bound to a different value up here, which was 100, result never changed down here. And when it wasn't doing it right, it still was. It just we had the same variable name, so the debugger thought it was the same one. So that's in a nutshell how references work. Is that we want to reference here result bound to be just like another name for this particular variable once we bind it, as we call this function. You don't have to do this in functions. You can also do it outside of functions, and just like I want to in reference result bound equals result. This works. It's not very it's not a common way because it doesn't give you any extra functionality when you do it within the same function, because you could just use result right here and get the same. You'd have the same variable. So I want to step through this example one more time now that we've changed result bound, and kind of hammer home one final time just what a reference really is. As you can see, result bound is still a reference because I changed it back to a reference. So we don't really have an integer here. This is not really an integer. It's a reference to an integer. And we told it that that reference should be bound to result right here. When we step over, you'll see that result bound is 100. We go back to main. You can see that this variable has indeed changed, even though we weren't even in this function at that time. Okay, so that's the basics of references. And there is an important thing to know, that it can be any type. You can make your own class. I'll call it foo, and which is a common fake name. And we can have our foo down here. And then we'll take a foo reference, foo, get rid of all that, and I'll just call this some foo func. And this should compile. And it failed, of course, because I didn't write the constructor. And this is where it starts to get really interesting. Because what if this foo class was really big? What if it stored a lot of data? What if it stored, you know, like an array of objects, or lots of floating point numbers, or doubles, or long ints, or whatever, which is pretty common when you get into programming things that are more complex. So you wouldn't want to copy all that data if you didn't have to. Like if you had a function that had to take in a foo and do some stuff with it, you would want to reference the foo that you already made instead of copying all this data in here. So it is not only is it an optimization, which it is, but it's also a way of preventing copying of things. So if you don't want to create an extra foo and you just want to reference and work with this one foo class, then you would have to use a reference or a pointer as you pass them through functions. Okay, this video is about 15 minutes long. In the next video, I'm going to talk about pointers. And since references and pointers are very similar, they kind of do the same thing. They allow you to pass objects without copying. They just work in slightly different ways. And some people even say, though the specification doesn't specifically say, that a reference is really a pointer with a cleaner syntax. And that seems to be the case, but they do have some differences, and one is that you can pass by constant reference, and you can actually pass in a temporary object like that, and this should compile. Now if I turn off now if I come in here and I turn off extensions, which I forgot where they were at the time, somewhere in here. Microsoft extensions to the C++ language. There it is. Disable language extensions. No. Okay. You can't do this when you're working with Win32 directly. Okay, so it compiled. And there shouldn't be hardly any warnings here. Okay. Now if I take away this constant reference, rebuild, it'll actually fail. Because you can't pass a temporary as a reference. I mean, you've created a temporary here and you've passed it by reference. So this is referencing an object that doesn't really exist anymore, unless you catch it by a constant reference. Now it'll build and run. Now Microsoft has changed the C++ language in their own IDE and compiler so that you can pass just by reference a temporary. Then this gets way deep into C++ and specifics and stuff, which I don't really want to get into, but I thought I should tell you that anyway. Okay, so I'll see you in the next video.